Hello everyone, in this video I want to look at a type of numbers and what is BODMAS and use of calculator for GCSE foundation and higher exam. There are some fundamental topics in here, and there are some areas that even people doing A-levels, they might still need a bit of revision, especially in use of calculators for calculating complex formulas. Okay, I start with the types of numbers in here. We can divide the numbers to rational numbers and irrational numbers. Rational numbers are the numbers that we can write it as in a form of an integer, fractions or terminating or recurring decimals. And irrational numbers are the numbers that we cannot have a terminating, they don't terminate. So example of an irrational number could be a case of pi, which we use it to calculate the circumference or area of a circle, or for other purposes. So a pi, for example, is 3.14 and 159, and that would be continuing, and this number basically never ends. And the fact that we use 3.14 is a estimation, sort of a bit of estimation, and it does have some error, but we generally use the 3.14 or in a using a calculator we just directly use pi to reduce the amount of basically error in the value that we find. On irrational numbers, we have integers, which are whole numbers, could be minus 0 or could be positive. So any number, in a whole number like minus 3 or minus 1 or 5, or in some cases we can write it in the form of, say, minus 3 over 1, or say 10 over 5. 10 over 5 is a 2, is still a whole number, even that its form, the way that we write it is 10 over 5, but basically it is same as saying 2. So that is on integers, and then we look at fractions. Fractions are basically not a whole numbers. They could be cases that we cannot simplify to a whole number, like 1 over 2, or minus basically 10 over 13. So any fraction format that you're familiar, we can basically write it as a fractions. And then we have terminating and recurring decimals. And then I give you an example in here what terminating is. So for terminating example, we can say have 0.25, and for recurring we could have 0.13333333, which that 3 is recurring, and that recurring we show that like 0.13 with a dot at the top of the 3, basically showing that digit 3 is recurring. Later in another video I will show you how any fraction could be written in the form of a terminating or recurring decimal, or we can convert any terminating or recurring decimal into a fraction. Just to give you a quick idea in here, this 0.25, the fraction form of that is 1 over 4. So the fraction form of 0.5 is 1 over 4. Now the fraction point of 0.13333 and basically 3 recurring If we can, I'm just going to do a quick calculation here, and we can convert that to a fraction, but the detailed video about this will come later. So if I consider that a equals 0.13 occurring and time that a to 10, so 10a would be equal to 1.3 recurring. And if I minus this from each other, basically I will have 9a equals 1.3. Sorry, 1.2. 9a equals 1.2. I can say that a equals 1.2 times 9. If I time it to 10, I will have basically 12 divided by 90. And if we simplify that 12 divided by 90 even further, we will find out that is basically 2/15. So that number in here, we can write it as a fraction as a 2/15. So any fraction can be converted to a terminating or recurring decimal, and any terminating or recurring decimal can be converted to a fraction. So if we now go to the next page, and the concept of BODMAS, and we see what that BODMAS is. BODMAS basically means priority of brackets, others, divisions, multiplications, adding and subtracting when we work with numbers. And I have some examples in here, and we're going to discuss how this basically applies to different math operations that we do. So in here I have 6 minus 2 times 3. If I start doing this operation from the left to right, basically what I can do is that 6 minus 2 is 4, and 4 times 3 is 12. So 6 minus 2 is 4, 4 times 3 is 12. Now, if I basically show the same thing on a calculator and see, put the same thing on a calculator and see what happens. So I'm going to put 6 minus 2 and times 3. Okay, when we make equal, the number that we see in here is 0, which is completely different from 12 that we obtained when we do this operation from left to right. So what is the issue? So I can basically go back in here now and see where the problem is, and if we can now do it in a right way. So when we have this BODMAS in here, when we say priority of brackets, others, division, multiplication, adding and subtracting, is that just as an example in this in here, if we have a subtracting and a multiplication, we need to do the multiplication first, because that has a priority over subtracting. So multiplication has a priority over subtracting. So that means that we need to do this first, which is 2 times 3, which is 6. And then we have 6 minus 6, which is 0. And that is what we got in the calculator. So really, the calculator does this automatically, but we need to be aware that how this works, and especially we will come back to it. We will go through more complex examples to see some other complexities around using this, especially when we want to combine this with use of calculator. So in the second example, we have 2 times 9 plus 8 minus 22 divided by bracket 3 squared plus 2 bracket close, and that's equal. If we go again through the priority in the BODMAS, we have a bracket. So we have to do the bracket first. So that's the very first priority. And when we go inside the bracket, then we have a term which is 3 squared. 3 squared, or squaring, it is basically comes into under others. So squaring is one of the things that comes under others. So we have to do that first before doing the addition. So 3 squared would be 9, 9 plus 2 would be 11. After doing that, we come, basically, if I just simplify this now, this has reduced to 2 times 9 plus 8 minus 22 divided by 11. Again, before doing any addition or subtraction, we need to do the division and multiplication first. So multiplication, we have in here 2 times 9 is 18. 22 over 11 divided by 11 is 2, which is a division. So that is the first. So these are before this plus or minus. And at the end, we will have 18 plus 8 minus 2. And if we add these together, add and subtract, we will have 24. So the next example, we have a square root of 2 times 9 plus 7 minus 2 squared. In this one, we have to first do the square root, what is under square root first, and then do the square root, and then continue using the BODMAS for the rest of the expression. So 2 times 9 is 18, plus 7 is 25. So that would be 25. So this would be square root of 25 minus 2 is 2 to the power of 2. The square root of 25 is 5 minus 4 equals 1. So again, we did the under the square root first. We did the other because we don't have any bracket, 2 to the power of 2. And then we do the minus. This example, the next example here, it is a typical example of using a quadratic equation. And again, there would be a video about this later on this topic. But for now, if we have an expression like this, how we want to deal with this. On any sort of fraction example, it is important for us to be able to do the numerator first and denominator second, and then we need to do it numerator divided by denominator. So in here, when we come to the numerator here, inside that we are going to again do this section first and do the square root, and then minus 12 plus that would give us the numerator. So that sort of organization, that's important to consider, otherwise we will get wrong answers. So we have 12 squared, which is 144, minus 4 times 3 times 10. 4 times 3 is 12, times 10 is 120. So 144 minus 120 is square root of 24. So we will have minus 12 plus square root of 24 divided by 2 times 3, which is 6. Can we simplify this further? We can simplify this further because 24 is 4 times 6. So, and 4, we can basically write minus 12 plus square root of 4 times square root of 6 divided by 6. And square root of 4 basically is 2. And we can factorize the 2 at the top. So we will have 2 times minus 6 plus square root of 6 divided by 6. And the final answer would be minus 6 plus square root of 6 divided by 3. because we are simplifying this 6 and 2, so this would be 3 and dividing by 2, and 2 divided by 2 would be 1. The final example that I have in here is when we have brackets inside brackets. So when we look at the final example, we have a one bracket which is in here, and then we have another bracket inside and another bracket again inside. So we need to start from the most internal bracket first. So 7 times 2 minus 8. So what we're going to do in here, just on a 7 times 2 minus 8, we know that the multiplication is the first. So we have 7 times 2 is 14. We need to do that first. And then 14 minus 8 is 6. Now 3 squared times square root of 4. 3 squared is 9. Square root of 4 is 2. 9 times 2 is 18. Now that we did the brackets inside, we come to the outer bracket. To do the outer bracket, basically what we have is 2 minus 6 plus 18. 2 minus 6 plus 18. So 2 minus 6 is minus 4, plus 18 is 14. So that would be 14. And now 12 minus 14, the answer would be minus 2. So the answer would be minus 2. So it's important to consider how this works. Again, the priority is with brackets. Then we have other, which includes squaring or rooting, division, multiplication, adding, and subtracting. Now, if I go to the next page, now we want to sometimes basically use make the right use of calculators. And also in some cases, if you put 6 minus 2 times 3, the calculator automatically will recognize that it has to do the 2 times 3 first, and then after that would do 6 minus 6 would be 0, as we showed on the calculator. So in some cases, it just happens automatically. So, and you need to identify and distinguish between the cases that it does happen and it doesn't. Second case is when we have a case of, for example, we have minus 2 squared. In here, I have put bracket minus 2, bracket close square, versus minus 2 squared. So what is the difference? Maybe we can just try to basically read them and look at the difference. With the bracket, I would say minus 2 squared. So minus 2 in bracket is squared. When we say minus 2 squared, we say minus 2 squared. So 2 squared is separate from the minus. Now, so the answer for this is basically 4. Answer for that is minus 4, because that minus is separate from 2 squared. So we have the minus first, and then we have 2 squared. But in the left-hand side, when we have minus 2 squared, this basically means minus 2 times minus 2. One of the critical mistakes most of students do in GCSE is use of calculator, and especially when we have a minus numbers. We need we have to do a very sort of be focused if we use a calculator and we are dealing with the minus numbers. In most of the cases, we need to put a bracket around the minus number inside the calculator to get the right number. Otherwise, we are getting a wrong sign, and therefore the final answer would be a wrong answer. So the example in here, I have brought the previous example in here. In the last two that we see in here, it is the same two expressions. One has 10 in here and one has minus 10. As you know, when you put a times minus 10, you can't really on a calculator put times minus 10 unless when you are putting this section into a calculator, you need to write it like 12 squared minus 4 times 3 times minus 10. So otherwise you will get an error without those brackets. So it is important to use the brackets as much as we can when we have minus numbers. The other issues with the calculators happens when we have a fraction. So I'm just going to show you another basically page which basically shows the problem. If you look at this one in here, I have basically changed the bottom part for this sake of this example to 2 plus 3. So there are calculators that they have a fraction sign, which the one that you see in here. So there's a fraction sign. You can press on a fraction and then you can put the numerator separately and denominator separately. But there are calculators on the left hand side which they don't have a fraction sign. Basically you need to do this without use of that fraction feature. On the left hand side, at the bottom of this part, I have put exactly what needs to go to the calculator, and you can see the position of different brackets. And as you can see, there are many brackets in here if you want to do this in one go on a calculator. So the reason, I'm just going to explain each one of these brackets. The reason that we have this bracket, and this total bracket there, because on a fraction, we want to divide the numerator to a denominator. The whole of numerator over the whole of denominator. So if I don't put this fraction, for example, this brackets in here, what that basically means that you can calculate the top numerator and divide by 2 plus 3. Rather than dividing by 5, the calculator would divide it by 2, and whatever you have, then it would add 3, which is a wrong answer. So you really need to have the whole thing at the numerator divided to the whole thing at the denominator. So that's why we do need these extra brackets. Now, looking at the other types of brackets in here, this internal bracket is the bracket that we need for that minus number, which I just discussed a few minutes ago. Now, then we have another bracket in here, which is basically this one and this one. That bracket is important because we want to show the calculator to just basically show the calculator that we need to square root the whole 12 squared minus 4 times 3 times minus 10. So when we do the calculator sign, if we don't do that, there could be cases that we are just square rooting 12 squared and then the rest is not squared, so which is again the wrong answer. So on the right hand side, however, when we have a calculator that has this sign, we basically press that sign, we go at the top and we type this at the numerator, and we type this at the denominator. As you can see, it doesn't mean that we don't need to put any bracket. We still need to put these brackets and this brackets, which is because of the minus number and because of the whole of this square root for the whole that expression under the square root. But because we have that sign, we do not need to put these extra brackets at the top and at the bottom. So it automatically, the calculator automatically calculates the top and then divides to the denominator. Yes, the other thing that we need to look at in here is that some students, they could say that, okay, we do all of these separately, and then we write it down in some point, and then we combine and we calculate the final answer. For example, if I just go looking at that sort of option, is that we can say that, okay, 12 squared is 144, minus 4 times 3 is 12, times minus 10 is minus 220, and minus 120 would be plus, so 144 plus 120 would be 264. So you could maybe go to your calculator and basically find out 264 and square that. That is 16.248. If I round it to 2 decimal, that would be 16.25. So you could come and say, okay, minus 12 plus 16.25 and divided by 5. And you simplify that, and if you do this on calculator, you will get 0.85. Also, this is giving a right reasonable answer. It is not exact answer. And because of that rounding off, we have lost some precision in the answer. And if we put the whole thing directly into the calculator, including square root of 264, as I just mentioned in here, the answer that we will get, which is a more exact answer, not completely exact, but it is much more accurate answer compared to what we have, is that it is 0.84 and then 96. Yes, the difference between 0.84 and 0.85 and 0.8496 is not that huge, but in some cases, when we are looking at more complex expressions, and when we have very small numbers or very large numbers, these make a relatively considerable difference. So again, it is a point that you need to look at when you can do it, and if the error is right, error level is fine to look at separate parts. As long as you do keep a right number of digits when you are rounding up numbers, that would be an acceptable answer to simplify different parts and then put all of it together into finding the value of a complex expression. I hope you found the video useful, and please do look at the video referrals during the video play. Depending on your understanding of the topic, if you think that you can go faster, you can move on to the next videos that are slightly more advanced topics, or if you find it hard, you can go back and revise some of the less advanced topic before this video. Please visit our website on mathsraven.com for more math resources, and subscribe to our channel for your support and for receiving updates.